hurricane winds command tremendous respect. But again, it's the tidal surge pushed ahead of the storm that causes a majority of the damage and 90% of the deaths. Two hurricanes crossed the exact same coastline of North Carolina in July and September of 1996. Point of landfall for both Bertha and Fran was at the Cape Fear Southport area just south of Wilmington. We begin our study with the stronger of the two storms, Fran, which came ashore just before dark on September the 5th. Fran started as a tropical depression west-southwest of the Cape Verde Islands, then strengthened to a tropical storm near longitude 49 on August the 28th. The hurricane moved generally west-northwestward for several days, briefly threatened Florida, then tracked steadily north-northwestward into the North Carolina shoreline. The satellite presentation of Fran just before, during, and after her maximum intensity show a well-organized and quite large hurricane approaching the southeast U.S. coastline. With a large eye and classic spiral banded appearance, Fran bottomed out at 946 millibars, with sustained winds near 130 miles per hour. The towering cloud tops of the strengthening wall cloud surround and rotate around the wobbling eye, as the entire mass of the hurricane plods towards land. The cirrus outflow, spiraling out clockwise above the hurricane, stretches all the way from the island of Cuba northward past the Virginia Capes. As the storm neared the coastline, it weakened a little and the eye became less defined. A closer look still shows a well-organized system whose northeast quadrant is constantly pushing the ocean ahead of it towards the North Carolina beaches. The center of Fran's eye finally came ashore south of Wilmington just before sunset on September the 5th. Wilmington radar reveals the strongest echoes northwest of the eye as it made landfall. The southern half of the storm appears quite weak. The video coverage of Fran begins at Carolina Beach during the late afternoon.
hurricane conditions should be rapidly coming to an end. If you live in a beach community, mobile home, or in a low-lying area, you should evacuate to a place of safety.
The 5 o'clock position, 32.9 north, 77.9 west, moving toward the north-northwest near 16 miles an hour with maximum sustained winds of 115 miles an hour. Minimum central pressure is 953 millibars. Intermediate advisories will be issued by the Hurricane Center at 7 to 9 p.m., followed by a complete advisory at 11 p.m. The flash flood watch is in effect for all of southeast North Carolina and northeast South Carolina. Rain bands from Hurricane Fran have already reached the coast, producing 1/4 to 1/2 inch of rain. Heavier rains are on the way as Fran continues its track to the north-northwest. Rainfall amounts of 5 to 10 inches are expected along the path of the hurricane. These heavy rains will cause extensive flooding as soil conditions remain saturated from rain during the past couple of days. Ditches, small streams, and creeks will overflow quickly and cause nearby roads to flood. Lowland and urban flooding will also occur. River levels on major rivers across the region normally rise slowly. However, with the excessive rains expected, water levels could exceed flood stage before Saturday. People living in flood-prone areas along major rivers or creeks or in poor drainage areas should move to higher ground.
eye wall. It's dead. It's dead calm here now.
Oh,
Yeah.
well, nothing like a bullseye.
Yeah. Well, that's why I figured to go over here. I figured it was going to pull this stuff.
The next video segment of Hurricane Fran was shot just a short while later, 15 miles north of Carolina Beach, just east of Wilmington. The exact position is on the mainland side of the Wrightsville Beach Bridge. Winds are already gusting over 50 miles an hour as the photographer arrives on the scene.
Rock and roll. Base of the bridge to Wrightsville Beach. That's the time. It's quoted somewhere. Where the water level is. Beach Bridge on the mainland side.
The next morning, east of Wilmington, the results of Fran's tidal surge is strikingly evident. The damage survey tracks westward back to Wilmington proper. Storm chaser Jim Leonard returns to the Carolina Curie Beach area the morning after Hurricane Fran's onslaught to photograph many of the exact locations he filmed during the height of the storm. We now return to early July when Hurricane Bertha formed further east than any tropical storm on record for so early in a hurricane season. Bertha tracked generally west-northwestward towards the northern Leeward Islands and increased gradually in intensity. When the eye crossed over the British and U.S. Virgin Islands on July the 8th, sustained winds topped 85 miles per hour. The storm turned northwestward, then north-northwestward thereafter until landfall. At maximum strength, Bertha's lowest pressure read 960 millibars, with sustained winds of 115 miles per hour. The loop shows a tight eye, round, central dense overcast, and excellent outflow as Bertha crossed the North Carolina coast. The satellite and radar presentations revealed a quite concentric and well-organized system. The heaviest radar echoes at the time of landfall were located north of the eye along the barrier islands. Our video coverage of Bertha's landfall begins at Surf City, North Carolina, as huge sections of the fishing pier crash into the tumultuous surf.
Oh! Man alive! Oh! Ocean. Over the dude. Tidal surf. Ocean, I think. We're in the eye. I'm in the eye of the hurricane. I'm in Surf City. Woo-wee. What's your name?
I'm Trapper.
Richard.
Nice to meet you, Richard. It's just an old fishing village for 50s and
Recon was getting 105, and you usually get 80 or 85% on the ground.
What do you think the biggest one? Man, that is beautiful. You ever get out there and surf?
I get seasick in 2 feet.
He likes a big storm.
Do you guys?
You know, we walk along the beach on calm days, and he doesn't even barely want to get into the water except to dip himself a little bit. As soon as something like this starts kicking up, man, you can't get him out of the water.
That's funny.
Yeah, yesterday there were cars out there where it's missing. Hey, get out of here. Hey, it's actually part of the building. You know, high tide comes up to where the end of the pier is there, normally, on a good full moon high tide.
That's the shoreline.
Yeah. And low tide will be about the end of the building there. On a real low tide. Up by, what the hell? Oh, here's the eye.
Here it comes.
How about
Up to over an hour. It's like 30 miles wide. But it depends if we get the middle of it or the edge. We're in the eye, folks. This is Surf City, USA. How many times you get to be in the eye of a hurricane? That's right. There it is, right up in it. There's the ring. Go. In the eye of the hurricane. You know how rare a picture this is.
earlier?
No.
About an hour ago. Did it again.
The eye's closing in. I think we're about to get in the second half. For a while. Rocked and rolled. I guess so. I'm still at Surf City. I was in the eye for 2 hours. I don't know how good that picture came out inside my belt, my diving belt or whatever. It might have been some autofocus problem, but I'll find out. Right now I'm taking a picture of two policemen removing the roadblock.
We now step back a few hours to the first point of landfall for Bertha's eye. The following live-action footage was shot at Southport as the eye wall moved ashore.
That's real trees going down somewhere. I heard a big crack. A crack and a crack. Good one there.
Coming back out at you, so stay inside and do not...
Downstream. It's completely blocked.
And that's Highway 50.
An aerial survey taken September the 11th snapshots the most extensive damage wrought by Bertha and Fran combined. This exemplifies again the high-risk behavior of humans building their homes on sand dunes and barrier islands. Our next segment details some of the important scientific data associated with Hurricanes Fran and Bertha. This recon plot details the wind field of Hurricane Fran when she reached maximum intensity. The airplane measured winds of 113 knots just northeast of Fran's eye. Highest winds clocked in the western semicircle were 95 knots on this pass of the hurricane as it moved northwestward, well east of central Florida. The barometric pressure at this time read 946 millibars. A later flight, several hours before landfall, detects a maximum wind of 110 knots well northeast of the eye, with hurricane winds encroaching the coastline at Southport, Cape Fear, and coastal towns near the South Carolina-North Carolina border. Study of this data reveals a large eye and a several hundred-mile expanse of hurricane winds across Fran's circulation. The following three charts compare three favorite forecast models and the official National Hurricane Center forecast track to the actual path Hurricane Fran plotted. 72 hours before landfall, the GFDL, an official forecaster, took Fran to near Jacksonville, Florida. The BAM deep layer had Fran approaching central South Carolina, and the NHC-90 brought the hurricane ashore at the border of North and South Carolina. Fran's actual track took the eye inland over extreme southeastern North Carolina at a time quite similar to all the forecasts. 48 hours before landfall, the NHC-90 model now slowed the hurricane down and headed offshore Jacksonville, Florida in 3 days. The GFDL forecasted landfall near the South Carolina-Georgia border in 2.5 days. The BAM deep layer kept the eye well offshore for 3 days, heading northwestward. The human forecaster predicted landfall in 50 hours in far southeastern South Carolina. On September 5th at 00 Zulu time, 8 p.m. September 4th, the forecasts all put the hurricane ashore within 60 miles of the South Carolina-North Carolina border. The BAM deep layer's forecast for landfall was quite precise as to timing and location. Each of the other models was slightly to the left of the actual path. The official NHC forecast verified with about 80 miles of error, slightly less than their average 24-hour error of 95 miles. This low-angle satellite loop steps through Hurricane Bertha's approach to the North Carolina coastline. The banded-type eye of this well-organized storm becomes even more pronounced at landfall, as depicted in the loop and on the radar presentation from Wilmington. The following short lecture by Dr. Richard Pash of the National Hurricane Center summarizes both hurricanes Bertha and Fran.
Well, Bertha was an interesting hurricane in the sense that it was a very early season hurricane to come from the Cape Verde region off of West Africa. If you look at the track, you can see this long track originating down here to the southwest of the Cape Verde Islands. It's one of the farthest east formations that we've seen for so early in the year, and it followed a long, fairly smooth track, gradually turning northward in the far western Atlantic and made landfall as a Category 2 hurricane on the Saffir-Simpson scale just to the southeast of Wilmington, North Carolina. It was a Category 3 hurricane briefly, a major hurricane, when it was located here just to the north of Puerto Rico and the Mona Passage. It caused significant amount of damage due to storm surge, flooding, and intensified a little bit just before reaching the coast. It weakened somewhat here off of the Bahamas, and then it re-strengthened momentarily before crossing shore, which did cause some additional problems. In general, Bertha was fairly well predicted. The track prediction models did a pretty good job. The Hurricane Center forecasters used all of this information to predict that the hurricane would reach the coastline somewhere in the lower Atlantic shore here, gradually focusing our track towards the North Carolina coast. It did threaten Florida briefly, and we did have to put up a hurricane tropical storm warning for a portion of the Florida East Coast. However, that proved to be unnecessary as the hurricane turned northward toward the Carolinas, as had been anticipated, although there was some uncertainty for a while there as to just when it would turn northward. But the main threat did appear to be farther north all along. And again, we were lucky that it was not a major hurricane when it reached the shore, but it did re-strengthen to a Category 2 hurricane and caused significant problems along the beaches in North Carolina. The main interesting aspect was that it was early July, and to see a hurricane come from the Cape Verde region in early July is most unusual. There have been very few, if any, that have developed that far east so early. Fran was a fairly typical Cape Verde hurricane, forming in the far eastern Atlantic near the Cape Verde Islands off of Africa during a period of quite a bit of activity, which was similar to what we had seen the year before in 1995, when strong tropical waves were emerging from the coast and developing. This one did develop into a depression in the far eastern Atlantic, but did not strengthen immediately. It weakened, the intensity sputtered up and down for a while, eventually becoming a tropical storm while located a good distance to the east of the Lesser Antilles, threatening the Lesser Antilles for a while. However, there was enough of a weakness in the pressure field to the north to allow this tropical storm to veer to the northwest and discontinue the tropical storm warnings that we had in effect for the islands of the Northeast Caribbean. It then turned back to a more west-northwest track and strengthened significantly, and as it was approaching the Bahama Islands, became a Category 3 hurricane on the Saffir-Simpson scale, and the maximum winds in the vicinity of 100 knots or so were more or less maintained for a few days as it approached the southeast U.S. coast. As compared to previous Hurricane Edward, and by the way, Hurricane Edward, which was moving over the area to the north of Fran, appeared to be interfering somewhat with the development of Fran. Most likely that was one of the reasons why Fran did not strengthen early on, was because the low-level flow into Edward appeared to be competing with the air that would be flowing into Fran, and so we saw Fran more or less suffering at the expense of Edward. Eventually, Edward moved north and out of the way and got farther away from Fran and allowed it to develop significantly, and as I said, it reached Category 3 status on the Saffir-Simpson hurricane scale, eventually turning toward the northwest. Here you can see a picture of it when it was quite well developed, and this hurricane ultimately moved into the North Carolina coast in the vicinity of Cape Fear. It was predicted to make landfall somewhere in the southeast coast, originally more towards the South Carolina area. Eventually that predicted track shifted northward by a state. However, it was apparently certain that it was going to make landfall somewhere along the southeast U.S. coast because we had a large high-pressure area situated to the north. Our track prediction models were in fairly good agreement, although we did have one model which predicted it was going to turn north and stay offshore, that being the UK Met Office model. However, the hurricane did eventually make landfall near Cape Fear as a major hurricane, and so far the most damaging hurricane of the year. It arrived around the time of low tide, which helped to minimize some of the damage. Unfortunately, it was such a large and powerful hurricane that there was tremendous flooding anyway, especially after the center moved in. The water remained over the area because the tide was rising and there was a long period of onshore flow. It continued to move northward towards the eastern Great Lakes and finally dissipated. And as I said, it was the most destructive hurricane of the year. Damage is going to run into the billions of dollars. Well, the question has been asked a lot whether it's unusual for two hurricanes to make landfall in nearly the same location. It is unusual, but we have seen a run of hurricanes to move up the area there from the North Carolina coast northward. For example, in the mid-1950s, I believe we saw at least two, maybe even three hurricanes visit the same general area in the same season.